So today I will be making aluminium oxide or hydroxide. Just that I wouldn't be using any hydrochloric acid nor sodium hydroxide to do so. All I will be using is a bit of table salt, sodium chloride, aluminium and electricity. It's a pretty straightforward procedure. There is a sodium chloride solution in the beaker. I add in the two electrodes, which are both aluminium. At the anode, the positive side, chlorine will be created, but the chlorine attacks the aluminium to form aluminium chloride, which comes into solution, and once it comes into solution, it reacts with sodium hydroxide, which has been formed by making in the chlorine production at the anode, at the cathode, the negative, and that creates aluminium hydroxide and sodium chloride once again. Then the aluminium hydroxide can be simply filtered and it can be heated to about 200 degrees, something you can make in the oven, to make aluminium oxide. So I think we can start the experiment. Right, I have my sodium chloride solution, about 80 milliliters of it. It doesn't really matter the quantity or the concentration. I have it saturated right now, and I just place the electrodes in and start up the power. Why isn't this working? Right, I have found a reason for it not to work.
No, I have.
Yes, my brother actually has found the reason why it wasn't working. The trusty computer power supply to alligator clip converter wasn't really wired up well, and so it didn't work. Actually, a spoiler alert, I am doing another project which is much longer when I'm filming this, and that might partially be the reason why it wasn't working. Maybe it was wired up wrong and was giving me very little voltage. Who knows? Might be a reason. Right. I also have it here cloudy, and that is due to the fact that, to check if it actually worked, we actually started up the cell, and it was very quick because we set it to 24 volts and made a lot of aluminium hydroxide in here, and also heated up the wires a lot, so you need to remember to use a lower voltage. Right, let's start it up again. There are a lot of hydrogen bubbles coming off the cathode. There are a few bubbles coming off the anode. That is oxygen. You do not worry, those are not chlorine. It's just because I didn't use a lot of sodium chloride. Also, pretty annoyingly, the anode is self-destroying itself into a lot of aluminium pieces, which are going to be a pain to separate. Right, the wires are heating up much less. They're still warm, and also the beaker is becoming hot. I actually thought about that earlier. I have a can of baked beans, I think. I don't know what it actually is. I ripped the label off a lot of time ago. Just to cool it down. It's full of water. That should cool it down. Hopefully. It's not much water. It's not going to be a long time until I stop the cell. I'll just wait for about a minute or two or three. So I have run the cell for about a minute. I actually need to start it and stop it because the wires were overheating, and that minute counts in those starting and stopping of the wires overheating and the actual cell runtime. The electrodes have now a very obvious difference. The anode has been eaten up, the cathode hasn't. I believe that now there is about a 2 gram difference in between them. That's how fast our cell was. And now for the actual beaker. All this cloudiness is aluminium hydroxide and a tiny bit of pieces of aluminium, which, as I said, the anode was self-destroying itself. The beaker is actually quite warm. Also, I wouldn't really be boring you with the filtration. It's quite an annoying step and it takes a long while. After the filtration, you simply need to take it and put it in the oven at about 300 degrees at a bit more than 200 degrees Celsius. Aluminium hydroxide dehydrates into aluminium oxide. Aluminium oxide is a really useful chemical. I've seen videos about making it for a lot of different reasons. Some made it to make synthetic rubies and sapphires. Some used it as an abrasive. It has a 9.8, I think, on the Richter scale. And really it has a lot of uses, and it's actually quite expensive. At least I found it on Amazon for £55 for 1 kilo, which makes it, for me at least, depends from position and things like that, one of the chemicals that are actually cheaper to make than to buy. Alright, I am in my kitchen to dehydrate the aluminium hydroxide, which I have here. It actually took very little time to filtrate, only about 10 minutes. I expected it to take about 10 hours, but that's a good thing for me. Also, I need to mention that it is not the smartest idea to dehydrate your aluminium hydroxide in the oven you're using to cook food. Because aluminium hydroxide isn't really toxic. I mean, if you bite into a piece of aluminium, you'll be fine. It's not like lead or mercury. But it isn't very biocompatible like zirconium, niobium, or titanium. So it isn't the smartest, but you should be fine as long as you clean your oven well. I am not taking any responsibilities in case of anything going wrong with this. If you do have an oven that you're not using to cook food, I highly advise you to use that. You can use a Bunsen burner or really anything, just that I don't have a Bunsen burner or a lab oven. I hopefully will be able to buy something like that in the future. Right, anyway, I will need to move on with the experiment because this is my only way of dehydrating the aluminium hydroxide. The first or the second? Okay, that's in. Let's see if I can manage to turn on an oven properly. This 300. Wait, is it this one? No, I don't think. Oh no, that's the bottom one. Oh. It's this one. Maybe if I turn the temperature on, it might work. This isn't working. Wait, is this even degrees Celsius? Wait, I can spin it both ways. Does it even matter?
Don't worry, I'm gonna help you.
Okay.
So how many degrees do you want?
300 degrees Celsius.
Okay.
That it? Well, my brother came to help me after a long time of me fiddling with the oven. Turns out he's 10 and he can turn on an oven properly. I am 13, I think, and I cannot turn an oven on properly. So, I have finished dehydrating my aluminium oxide. I only left it in the oven for about half an hour. It isn't completely dehydrated, but it's mostly aluminium oxide, and I'm fine with that. I will be storing it in this vial. I chose this vial because actually I brought it to school once, and the lid didn't come out really intact. So I said to myself, I cannot store anything volatile in it, but aluminium oxide melts at about 2000 degrees, which is really a bad definition for volatile if you're using aluminium oxide, so I can store it in here. It's really crumbly because I dehydrated it and most of the volume went down, but anyway, I'm quite happy with it, and I am storing it in this tiny vial. I actually didn't expect that much aluminium hydroxide to yield me this little aluminium oxide, but oh well, it was a fun experiment. It was actually quite quick too, so yeah, I'm quite happy. In conclusion, this method actually turns out not to be more viable than just buying aluminium oxide. I didn't realize it would have made this little from so much aluminium hydroxide, but anyway, all my other videos were about making some chemicals for the sake of making chemicals, and not for having the chemical around instead of just buying it, which in most cases would be cheaper.